Okay, I'd made the video, edited the video, as in my next one to go on YouTube. I was all ready to go, and then I just had another quick thought. Which one? This seaweed. It's just, you know, I've got kind of a bit of an emulsion there going on. I've got, I can't believe I've lost these. Ah, there they are. Yeah, I've got quite a few jars of semi-dry seaweed there, chopped up in the blender. I've got this, which is what you've just seen in those jars, completely dry, bone dry seaweed. And from that, I put it in the coffee grinder, and I've got that, which again is powder, bone dry, nothing else in it, just seaweed. That's it, powdered seaweed. So what I did, I've just done this literally. You can see I've been messing around. It's Sunday, it's midday. I've got the window open if you can hear the traffic. It kind of smells a little bit in here today. Well, it's like, I do enjoy the smell. I love the smell of the sea. But seaweed is something else. And I've been cooking it and all sorts, so it's a bit, you know, I mean, I have got that there now, and you know, it's I've piped it up. Look, you know, piped it all up out the window. Look, see, it's not on at the moment, but you know, that's my. I'm going to build a little hood as well, so out of cardboard. No need for the, you know, massive expenses at this stage. But anyway, back to this. Literally on there, underneath that magnesium, is that dried powder. Nothing else, just that dried powder. I just wanted to try it in that form. To be honest, has it cooled down? Yes, it has. In there, I've just kind of half an hour ago taken it out of the oven, and in there again is seaweed. Obviously I'm just trying it. It's the first one, it's the first batch. Citric acid, and we'll see how that goes later on. But again, back to this, that's all that is, just that powder, not carbonized, nothing. And I thought, let's just try the voltage. Now I've literally just put that together, and I tried the voltage, and if you can see that, should be able to. Well, if you can't, let's do something about it. Can you see it now? Yes, you can. This is the voltage. 1.89 volts. It's not going anywhere, it's not dropping. .889. Well, I mean, you know, a fraction. What's that? Highly stable voltage. You wouldn't expect the voltage to stay at 1.8 volts, but I haven't tried that for current yet. But I'm going to try it now. If I can find, I'm in a bit of a muddle today. I've been messing around a lot. I'll tell you more about there it is. I'll tell you more about that in a minute. So, current. Have we got any current? My gut instinct is yes, we have. If we got that kind of voltage, my gut instinct says yes, we've got current. Hey. Now that is whizzing round. It's you know, it's not slow. That is whizzing round. I've kind of got to the bottom of this seaweed thing as well without this separator. It's all to do with alginate from seaweed. There is alginate in seaweed. I've read a paper on it. I've got the paper here. I've been printing off a lot of these papers. These are phenomenal. Now, new nanostructured lithium. Well, this is lithium silicon rechargeable battery, but this one really opened my eyes. For those of you who are, well, people say, why are you using like this carbon fiber weave, you know? And you know, a guy commented the other day, why is it so good and all that? Well, this paper, it was that bit that caught me, this silicon nanowire anode. And I looked at that and I thought, do you know what? Nanowires, okay. Cathode there is mesoporous carbon, lithium and silicon nano composite, all that, yeah, it's all there. I'm going to read that later, but it was that picture that caught my eye, and I thought, well, do you know what? I would not like to count those. All those fibres, I would just not at all like to have to sit down and count them. And that's kind of, I feel, what I've got. I've got my own little nanowires. Millions of them. I just would not like to count them. The same as you wouldn't like to count silicon nanowires, you know. So I've got a feeling that that's where I've got a bit of a surface area going on there, and I think that's why this stuff is so effective, even with its high resistance, because it's not a low resistance. In fact, well, I think I've done this on camera before, but I'll do it again. With, you know, memory wise, I don't know what to expect. I can't remember what it was. We'll change that to resistance. Right, can you see it? Yes, you can. And we'll go, actually, I think I'll clean these up first. Anyway, but I do these days. Let's see what we got. Okay, at 1 centimetre we've got 1.7 ohms. Now that's low, but in resistance terms for what we're doing, that's quite high. But let's call it 1.7 ohms. That's the resistance of this weave, and I've got my own little nano wires, if you like. So that should answer a lot of questions, really. You know, for those people that are wondering why I'm using it and why I've had good results and all the rest of it. So, do you know what? I'm going to stick with it for a while. Until I can well, get another sonicator again and start, you know, working with graphene and stuff. But I've still got to find ways around. It's okay producing graphene. You know, and producing an ink or whatever, but you need nanostructured layers, and that in my head now is a nanostructured layer. So I need to work now with the activated carbon side a bit more, see what I can turn that into, you know. So yeah, that's all that bit. I'll talk more about it when I understand it a bit more, because I don't fully understand it yet, but I'm getting there. You know, I'm having a bash, I'm trying. So anyway, back to this again. That's all that is. Dried seaweed. That's it. Now, we've tried the voltage, obviously. Get that meter back. Put it back onto volts in case I want to try the volts again. We know it spins that motor, but of course the ultimate test, I still haven't built my switches yet and my resistors for my. I'm going to do it today. I will do it. I need it desperately. So if I can find my short circuit lead, this other lead incidentally is from the power supply to charge this in a minute, if we have to charge it. I don't know where the other wire is. Oh yeah, there it is. So that's the other side to that charge wire. Where is my short circuit lead? Okay, follow the lead. There we go. Found it. Now this is going to be short. This is on 10 amp scale, so let's just try it. Wow, 60 milliamps. $50 milliamps. And look at that baby holding. I mean, that just ain't going anywhere, is it? That's 50 milliamps. And this is without charging it. I promise you, I have not charged this at all. Look at that. I have just got to build some more batteries with this stuff, I tell you. In all sorts of formats. I'm gonna I'll show you a paper in a minute appertaining to seaweed. I mean, look at that. That's, you know. I must admit, I've just moved slightly. I've actually just must have put a little bit more squared pressure on there. Yeah, I did. Now, interestingly, I've been talking about these things for quite a while. My little toggle clamps. So once they're screwed to the bench, I can just put some squared pressure on with that and just leave it and not have to touch it and press it and all that rubbish, you know. So there you go. That would be. I need to replace this for a piece of timber really, so I can still get some clips on or whatever I've got to do. But that's my toggle clamp. Look, that's how they work. And you just set your pressure with these nuts. So that's that. I'm going to order some slightly larger ones for the bigger cells, obviously. But for all this small stuff, you know, that's that. So yeah, back to this then. Now, ideally, because that's kind of hurting my finger again, what I really need to do, if I'm going to do this, because this looks like it's a bit of a good one. I just put one of these on there, so I don't have to hold it. And there we go. Self-contained. I made a coffee a while back. I'm just going to have a quick sip. That is incredible. That's as good as holding the current as anything else I've produced. That's a nice drop of coffee, that is. Look at that. another one of Kev's Seaweed batteries. I'll tell you what, I can't wait for RMS to see this one. I just can't wait. Well, unless he's perhaps done something similar, I don't know, but I haven't seen it if he has, so. Look at that. Oh dear. So there it is, as I said. So we've gone from that, which is your seaweed, dried it, ground it up, and it's in there. Now, I just want to let that run for a while, obviously, because, well, look at it. It ain't going anywhere, is it? I mean, to me, that's just opened up a whole new world. That. It's just, I'm looking at it and I can't believe it. That's 60 milliamps Bosch. And it ain't going anywhere. And you know what? I said it earlier on, it ain't been charged either. I'm just looking through my nano letters to try and find the relevant one on Seaweed, to show you why I think Seaweed has got these properties. Well, not the properties of what we can see there, but all to do with that the fact that we've got no separator, or no separator is needed. You see, some of the other papers I've been reading, look, interesting stuff that. Now, I actually figured this one out before really anti-corrosive magnesium hydroxide coating on AZ31 magnesium by alloy by hydrothermal method. That's a very good paper. That's a medical paper. It was all to do with you know, when they stick magnesium in people's bodies and it corrodes and stuff like that. It's a really interesting paper. Now, obviously, I was doing my hydroxide coating before I even come across that paper, and it was only really again down to RMS with his was showing us that Sylar method of whatever he was doing at the time. I think it was a capacitor layering up layers, and basically you know, it's what he said about a chloride, turn it into a hydroxide, and hydroxide is insoluble, and that just clicked like that, and that's what I did. So I moved this now. I think you've probably seen enough of that. Now, as you know, that is a dead short. It's not a resistive load or anything like that. It is dead short. So anyway, I'm going to try and find this Seaweed one, if I can. Oh yeah, that's a good paper. That's where it is. Polymer extracted from seaweed may improve battery performance. No shit, Sherlock. Sorry about my French, but you know, yeah, it's a collaboration between researchers at Clemson University in Georgia, promising new binder material for lithium-ion battery electrodes, known as alginate. Now, I've used alginate in the past, alginate to me is what dentists use as a mould in your mouth to form the shape of your palate, or whatever they're doing to, you know, to make false teeth and stuff like that. So they've got an exact replica of your palate, or, you know, inside of your mouth. So that to me was alginate, but obviously yeah, polymer extracted from seaweed. I think it's this alginate that's allowing us to not use a separator there. So I'm going to do a lot with this now, with seaweed. I've got a lot of plans for it, not just, you know, the carbonisation, especially now I'm looking at that. I don't know how long that's going to last. It's in a dead short, and it's still 60 milliamps. It's not budging. Now what's that mean? Well, it's got to be. Well, I'm looking at the timer on my phone. I know I was chatting about stuff before we put this on, but I've got 21 minutes on my phone. So I'm going to have to re-look at this before I tack this on to the end of my other video, because it's going to go on the end of it. That's a certainty. I mean, earlier on you would have seen the other seaweed battery, which was just bare seaweed that worked, but this is just something else. Now that there is going to be not in this video, it's going to be in the next video. I was having a play with that earlier on, and that's lead. It's a part of a cell taken from an old lead acid battery, and it was all neutralised, they're all washed. It's in a sorry state, but it's still got a bit of lead on it, and I was having a play with that, obviously with a separator and all the rest of it. And oh, it's gone down to 50 now. Look, that's fine. You know, that has not been charged at all. So this I tested with my weave, I tested with that graphite, I tested it with magnesium, and I tested it with zinc. Not that piece of zinc, but that piece of zinc. Yeah, that's the one. So yeah, the next video you'll see results from that. Now this is going to be a lengthy one again, isn't it? Oh no, I might just keep this as a separate video, actually. Just let it go on a bit and keep it as a separate video. That's all. Yeah, definitely, because it's just too interesting, isn't it? You know, I don't want to edit this, I don't want to cut it, I don't want to do anything. I've got to have that. And you know, if there's any skeptics out there as to whether this is a dead short or not, that's one lead going to the meter. We'll put that there, and my copper strip on the weave. There's my it's not a current collector as such, but it's just a connection, and there's the other lead. So there's your two leads. That is a dead short to that meter on the 10 amp scale, and we're still on 50 milliamps, and it still hasn't been charged. Coffee's nice. Yeah, bye. Oh, that'd be interesting, actually. We won't let him switch off. What we'll do, I just I know it's a bit meaningless while this is in a short, but now that's saying 21 millivolts. So that's what you'd expect, of course. I mean, from some of my other cells, I've got sort of 300 millivolts. Now there's no activated carbon in there, nothing, just what I've shown you. Okay, that's dropping again to 40 now. That's great. That's, you know, couldn't grumble about that at all. I've just knocked that. Okay, not detrimental. So I'm just reading this now. This polymer extracted from Seaweed one. It goes on to say, you see, the other thing is, it tells you how to extract the polymer. Na2CO3 process. There it is. That generates a material with a uniformly distributed carboxylic groups. The anodes can then be produced through an environmentally friendly process that uses a water-based slurry to suspend the silicon or graphite nanoparticles. Obviously that's in this lithium battery. The material may solve one of the most difficult problems limiting the use of high energy silicon anodes. Now that's where I am at the moment with some of the behind the scenes stuff that I'm doing. Silicon. Hence that stuff. Man-made silicon carbide as a crystal. Now, thinking about that, I've got a feeling that I know, or I'm starting to get the gist of, what this guy's done in America with these other cells. You know, a flat cell similar to my flat cell, if you like. I've got a strong suspicion now, because he said, quite openly said, that he used silicon crystals, and he's had to put these in a gel because, and this is a fact, that silicon will expand once you put sort of pass current through it, if you like. They'll expand up to 300 times. So I think I'm kind of starting to realise what he's done, roughly, and why he's done what he's done, and you know, the way he's done it. And I think he's got a big problem with expansion, hence all these new bolts that you see on his cells. Don't get me wrong, I'm not knocking the guy, I wouldn't do that at all. I think, you know, the concept is brilliant, you know, and what he's done is brilliant. I wish I could remember his name. So look, 30 milliamps just put together there in my slap hazard fashion, and it works. It hasn't been charged. I can't wait to see what this does when it gets a charge. So what I feel bound to do is just put that there again, because that's what you're looking at in there. Well, the timer's on 29 minutes at the moment. Now, what I'm going to do when this is over, I'm going to put this first bit on YouTube as a separate video, as I said, and I'm going to do it in two parts, because what I want to do when that finally gets down to, I don't know, I think 10 milliamps, I'll disconnect it and I'm going to see if there's a regeneration first. My gut instinct is that there will be, and I think I know in the back of my mind why there will be a regeneration. Now, depending on how far it regenerates, I mean, what I'll do is I'll give it time. I'll put a quick short on it, see what the current is, and if we back up to anywhere near 60 or 70 milliamps, I'm going to put that motor on it and I'm going to time it, because I think that will run on that for just, well, I couldn't even guess. My other one, which was a totally different architecture to this. Yes, we'd got the weave, and yes, we'd got the magnesium, but the coating on the magnesium was a totally different animal to what we've got there. So okay, we're coming on to 20 milliamps. Look, dead short. It's just, this is just unbelievable. I mean, whew. What, I mean, if you, any one of you now could take this to other levels. I know I'm gonna. I want to build a big one of these now. I mean, you know, I want to build one like that with my big piece of magnesium. $20 milliamps. Check the voltage, that would probably get something like 0.4 of a volt still. That's just, you know, from experience and what I've been doing and all the rest of it. So okay then, we're down to 10 milliamps. I'm going to disconnect that now. We know its capabilities. I'm not going to charge it. I'm just going to leave it and see how we go. So that's that bit. Leave that there. Check this voltage. Alright. Meter's bleeping at me. What does that mean? Don't know. Okay, I'll turn it off. Back on again. It's probably like me a bit now. It's got salt on the brain. Everything else around here has. Right. Voltage. Wow. I can barely say it. 1.264. 5. It's rising. I've got to do this now, haven't I? I've just, I mean, that's, I don't know, what's that, 30 seconds, 20 seconds, I don't know. I'm so excited. But 20 milliamps. Oh my word. I am just astounded by this. I just cannot even put this into words the way I feel. It's not like it's some, you know, huge great discovery, because I'm certain that someone else somewhere must have done this or tried this. They must have, but I've never seen it. You know, I haven't seen it on YouTube. Perhaps I should, you know, have a look at more Seaweed stuff. You know, I don't know, but I haven't seen it. So well, I can't wait to get this open now. I hope you're watching this still. It's just, this is, I'm more interested now to see if that's going to say 30 as in milliamps. Okay, no, that's fine. I'm gonna give that an hour and I'll come back. Okay, it's been about an hour, and obviously just come back to this. I'm gonna just try the volts, see what we've got. Okay, it's 1.27, so no massive recovery on the voltage, but I did say earlier on that, you know, the voltage will settle down to whatever. I'm just going to, as I said, quickly try that current. Okay, nothing spectacular. So I'm going to save this for the next video now. On the next video I will charge that and we'll see where we go. And if we've got a similar effect, then I'm going to put the motor on it and I'm going to time it. My other phone's on charge, so that's that bit for the timer. And yeah, happy days. I'm going to post this one. I just cannot wait to get this one on. It's just too interesting, this one. So yeah, that's it. Happy days.